Lesson 115, we're still on financial maths, and in financial maths, things have changed from grade 10 to this year. So you don't always have your interest per annum or per year, it's now per day, per quarter, per month, per half year, or biannually is the other word for that. So all of that comes into play now. Now, number 1 of exercise 4C. Johannes opened a savings account 20 years ago. On opening the account, he immediately deposited 4,000 Rand. He added a further 10,000 Rand 10 years ago. 5 years ago, he withdrew 5,000 Rand to contribute towards his uncle's funeral. That's the story that they can put in there, whatever they like. So he withdrew. The effective annual interest rate on his account was 7.2% per annum. How much money is in the account today? Now this was still timelines, but not with major things happening to the interest rate, because it was only per annum. If they had said that the interest rate was 7.2% per annum, compounded monthly, or compounded daily, or compounded whatever, something else, there was a difference. So this was still straightforward, but it was difficult because it was a timeline. So first of all, it was a 20-year thing. So the moment you see 20 years, and after 10 years something happens, after 15 years something happens, you've got a timeline. And the timeline is worth no marks. No marks. This is just to sort out the picture in your head. They said he opened the account with 4,000 Rand. So he put in 4,000 Rand when he opened the account. This is 20 years later, and I would like to know how much money he's got. That's the basics of it. But after 10 years, he added another 10,000. And after 15 years, so in other words, how long is this? 5 years. He withdrew 5,000. And in all that time, the interest rate that they gave me was 7.2% per annum. Not compounded something else, so per annum means compounded yearly. So that that was 7.2%, I taught you that this is the way I want you to do it, because you know that I is R over 100, that you should know. And if R is 7.2, that's going to mean that you're going to have 0.0722. So that's why I'm always going to say 0.072. And if it was compounded monthly, you would divide that by 12. If it was compounded quarterly, you would take that and divide it by 4. If it was compounded daily, you would divide it by 365. We had the discussion about leap year, etc. Are you with me? Biannually, you would divide that by not 6. Biannually means every 6 months, but how many times per year is that thing? Twice. Every 6 months means twice, so you divide it by 2. So that in a nutshell is what we've done. So now, to do the sum, there are different variations of methods. The one I would like to impress on you and ask you please to do, because you're going to confuse yourself otherwise, is to say, okay, let's take it bit by bit. Let's call this time frame 1, or interval. Or whichever way you'd like to say it, time interval number 1. We have definitely got, and this doesn't happen with simple interest, by the way. It will always be compound interest. So you're going to have a compound interest formula in which you know the 4,000 is your P. Your I is 0.072. And like I told you in the previous lessons, if there's on top of 12, you knew it was monthly. If it's on top of 2, you knew it was biannually. If it was on top of 4, you knew it was quarterly. If it's on top of 1, you mean it's annually or yearly if you want to. So then N is now what? N is 10 years. Because this was yearly, then 10 is the years. Now you could write it here. N is 10. But please be careful, the way I showed you, this must go hand in hand. If N is yearly or years, then the interest rate is also going to be per annum or per year. If this is per month, You're going to work in the time frames of months. If this was quarterly, you've got to work in how many quarters there are in a certain time frame. So to work that answer out, please give me an answer.
8,016,92544.
Okay, and why aren't we rounding off this money?
Because you didn't use it.
Okay, so because I don't go to the bank and withdraw it and put it back in again and see, this is 93 if you round it off, are you with me?
Yes,
But you don't round off because the money is staying there. But now, for the second time frame, you have a new amount because something's happening. You're adding 10,000. Why can I not just go from the start and say 4,000 plus 10,000 is 14,000, take away 5,000 is 9,000 and do one sum with 9,000? Because the interest is only on the 4,000 in the first 4 years. Then the 10,000 gets added to the amount that's already grown a lot. And then on that new amount, the interest is calculated. Then you take away the 5,000 only there, not from the start. So that's why you're working in time frames. Are you with me? So my new amount, or my new P for the second one, is going to be, take that amount and add 10,000, which is going to give you 18,016,925, blah, blah, blah. And don't touch your calculator because that amount is there completely. So for my time interval 2, my sum is going to be. Now, you can write that formula every single time that you use it, or you can now leave out the formula and just tell me this is now P, which is that 18,016,925 ... on my calculator. And the interest rate stays the same. Could it have changed?
Yes.
Could the sum have said, the moment I put the 10,000 in the bank manager liked me so much he gave me an extra % interest rate. Are you with me? Or inflation came in and they're giving me less, or whatever the story that they have. That could also change. But every single time something changes, there's a new time interval. And then that would be for a time interval of what? 5 years. Remember, N is years and it's per year. It has to go hand in hand. So that's going to be 5, and the answer is
25, 506, 719, etc.
okay. So then what happens for the new one? You minus the 4,000. That amount minus the 4,000 will give me how much?
5,000.
Sorry, 5,000. Give me how much?
20,506,719.
Right, so then my last time interval, and in a paper, a well worked out paper, there should be more than 3. 3 is actually the most that there is. For that time interval 3, you're going to have A is, that's now your new P. Your interest rate still stays 7.2% per annum. And this last section is how many years?
5 years.
Are you with me? Nothing with 20. The total adds up to 20, and that is still 5 years, and it still goes hand in hand with yearly, and this is then 5. Answer, please.
29,031,54.
Okay, and why do we round off now?
It's the
Because
final
that's the
amount.
final answer. That's when we are here. How much money does he have in the bank after 20
Years.
years? Timeline sum. With no problem, with the interest rates being monthly, quarterly, annually. Something changes there. Right. Okay, then number F says, still on page 302, Deirdre sold her house for a large amount of money. She wants to have 3 million rands for retirement in 15 years from now. So we're looking backwards, eh? Society Bank, or whatever the bank I'd like to call it, this is my Spalkwyks Bank, agrees to pay her 7.5% per annum, compounded semi-annually. There's a change. For the first 10 years, and then 8% compounded monthly for the remaining 5 years. So there's 2 differences. If she invests her money with them, what amount must she invest now to achieve her goal? If you don't draw the timeline, you're a little bit lost. You with me? So definitely she wants to have 3 million, yeah. Alright? She wants to have 3 million rands there, and I want to know, what amount must she invest now? So we're working backwards actually. So we don't know what this P actually is, and we could even call it X if you wanted. We like X in maths, right?
Yeah.
Okay, so then they say she has one amount, she's not putting money in and out, she's just putting one amount in there, and then she wants that 3 million at the end. How much must she put in? I don't know where she got it from, but how much must she put in? For the first 10 years, she had 7.5%. So there was 10 years, and then there was 5 years, right? Because it was 15 years. But then we must read about the I. For the first 10 years, the interest rate was 7.5%, but compounded semi-annually. So 7.5, I'm immediately going to write as 0.075, but that would be per annum. If it's per half year, if you want, per half year, semi-annually, whatever you'd like to call, you've got to divide that by 2. Then your n cannot be 10. It has to be 20 half years. Okay, remember I said to you, please don't get the idea. This is always divide 2, this is always times 2, because I've given you the time in months. Then you don't time it with 2. Are you with me? Yes, logically. How many half years are there? Right. Then, after that 10 years or 20 half years, it changed to an interest rate of 8%, and it was compounded monthly. So first of all, the 8% must be 0.08. Not 0.8, because that would mean 80%. That's fantastic interest rate for you. 8%, 0.08 per year, but then per month, you would say divide by 12 to make it per month. Now, please don't think it's a waste of time to write per half year and half years. Per month and months, because that makes you get that connection that it's got to be hand in hand. So that's why I can't use N as 5 here either. I've got to take it to months, which means 5 times with 12 months gives me 60 months. So that you can all the time realize the two go hand in hand. But the little problem we have, is we don't have a P. So, now what? But then we're going to use it as a variable. So we are still going to have 2 time intervals. For time interval 1, we're going to start with P that I don't know, and A I also don't know. But guys, that's so be it. P I don't know, but I do know that the interest rate was 0.075 over 2. We did a few of these sums last term, and we said, the moment that I read that, I must say, this was an interest rate done half yearly. The moment that I see the 12, I must know it was an interest rate done monthly. The moment that I see divide by 365, it's done daily. Divide 4, quarterly. Are you with me? Yes. So if you do it that technique I'm trying to push upon you, you won't get it wrong. Okay. And then 20 is half year. So reading this, I know it's half yearly. So that's 20 half years. Making sense for 10 years, right? So now, what can I do with it? You can work out that piece. But it's going to be something P or P something. Now whether you put the P in the front or the back, it doesn't really matter. Okay? But you're going to get some sort of an answer. Please, can you give me the answer? 2,08815. Okay, are you with me? And it's multiplied with P, whether the P is in the front or whether the P is at the back. Right? That, luckily, thankfully, we don't have to add or subtract anything from it, but if we had to, we had to. So we'd say that whole thing, like an X, plus say something like 1 million that you got from somewhere to put in there. Okay. Then we go to time interval 2. What happens with time interval 2? We still want to know what A is. Or do we? No, we know it. We know that A, the end amount, is going to be 3 million. That P here is what? That whole thing is my P. To on the 0.88151, guys, and please remember you didn't erase it from your calculator, you got the whole thing times with P. Right. So the P is the original that we want there. That I value there is now 0.08 divided by 12 monthly, and then this is going to be 60 months. What am I solving? 40. This is the variable. So now, in retrospect, I think maybe it would have looked a little bit better if I put the P
At the front.
at the front. Are you with me, guys? Have you got options? Remember what your middle name is? Alternative, right? So whether I put it in the front or the back or right at the back, it's fine. Okay. How would I then solve this issue? It's not very difficult. Time all of that together, and remember, this is what you've got on your calculator, don't touch it, otherwise you've got to redo it. So that thingy that's there, you say what? Times with, bracket, 1 plus fraction, bracket, to the power of 60. Get an answer, and what do you do with it?
You divide by 3 million.
You must take 3 million and divide by that. So please be careful, get to know your calculator, because for some bizarre reason I do it very archaically, very old-fashionedly. I'll do that and say divide by 3 million. Is that right? It should be the other way around. But there on your calculator there's a function that says that. Look for it. It's right there by your on switch somewhere over there on the right hand top side. What does that do with your calculator? Whatever you got, it switches it around. And what did I just do? I said this divided by that, and it shouldn't be. It should be this divided by that. And if I do that and I press that button, it's going to fix it for me. The more you know your calculator, the more you can do some things with it. Otherwise, you could have now actually gone and said 3 million divided by whatever that answer is on your calculator, and then get to your answer. Are you with me? Many ways to do it. The correct answer is
964.312,63.
okay, I got 62 when I worked it out. Do you think we're going to have a problem with it?
No.
Definitely not. Okay, they are strict about rounding off, but especially if you're doing 1, 2, 3 sums, and there's a little bit of a rounding error, I don't think there's much of a muchness here that you could get to that answer. So it's a little bit different. What did you see here? That you can alter the way that your interest is compounded. Interest was normally compounded in grade 10 annually, all the time. So in grade 10, you said to me it was years, and you were right in grade 10. But from now on, N is not years. N is a time. And the time has to go hand in hand with how your interest has been compounded. If it's compounded half yearly, your time has to be half years. Quarterly has to be in quarters. Semi-annually, half yearly, it's going to be in the amount of half years. Daily, it's going to be the amount of days. Correct?